look at is dividing polynomials but using long division. Okay, using long division. So recall and think about long division and remainders. Give me a number, Ryan. A number between 40 and 50.
45.
All right, give me another number that is not that does not divide into 45 evenly. That does not. 8. All right, so if I wanted 45 divided by 8, I say to myself, well, 8 goes into 45 times. Right? Then I have 5 left over. So we talk about something called a remainder, and you've seen this before, obviously. So think of this as far as long division is concerned. Oops. 45 divided by 8. If I'm dividing this, I put a 5 up here. Then what do? I know this is simple, but please just appease me for now. Yeah, multiply them and get what? R5. So I multiply these, giving me 40. Right? Multiply these two. I put a minus sign, gives me a 5. So 5R5. What does that mean? 5R5.
That 8 goes into 45, 5 remaining.
With 5 left over. Very good. Now, translate this result into a mixed fraction. Translate the quotient, the answer, 5 remainder 5, into a mixed fraction.
5 and 5 45ths.
5 and 5?
45ths.
Not 45ths. Something else. Eighths. It's the divisor, right? Not the dividend there. So we get, ready? Let's write this out. This becomes the whole number portion. This 5 here becomes the numerator of the fractional part. This 8 over here becomes the denominator of the fractional part. And it always works this way. Always, always, always. Okay, we need to understand this. If you don't understand this, you're not going to understand what we're doing in a minute. So the quotient at the top, 5, becomes the whole number. The remainder becomes the numerator. The divisor, 8, becomes the denominator. Okay, 5 and 5/8. Practice one on your own real quick to make sure you get it. Let's say 37 divided by 6. 37 divided by 6. Give me your answer in mixed number form, obviously. Now, what he got is a mixed number?
6 and 1/6.
6 and 1/6. He knows that because the 6 goes here. Multiplying these two gives you a 36. We remember to always subtract, giving you a remainder of 1. So it becomes 6 and 1/6. Okay, that's where that answer comes from. Again, the same exact setup. Are we okay with that, right? Let's think about this now with variables. So divide the quadratic x squared plus 2x plus 4, that expression, by the binomial expression x minus 3. If this had said divide 35 by 4, you would put 35 underneath the division sign, and you put the 4 on the outside. So since you're dividing this piece by this piece, put the quadratic underneath the division sign, and put the divisor out in front. Now, it's not easy. This is not an easy topic. It's kind of weird. I remember the first time I learned this, I was like, what the heck is actually going on? Because you don't have numbers anymore. What helps with this topic is practicing for sure. If you don't practice this, it's not going to get easier. So the first time might not be obvious. I'm going to step you through the first one. The first thing you want to ask yourself, and you might want to jot these notes down that I'm about to say. These are like the, steps. The first question is this. What goes here? What can go here so that when I multiply it by the binomial, and I'd have to distribute it to both of these, so that when I multiply it by that, I get the same thing here that's here. Again, let me just step through the steps one more time. What should go here so that when I distribute it to both of these, I get something that's the same here as what I see up here? X. Put an X up there for a second. Multiply x times x minus 3. What do you get?
Negative 3x.
Not negative 3x.
Or, no, x squared minus 3x.
X squared minus 3x. Now, I'm going to erase the red circles I have everywhere. I can't, of course. Great. I get x squared when I multiply x times x. Then I take the x multiplied by negative 3, giving me negative 3x. I line up my degrees. Squareds are here, linears are here. Now, with long division, whatever we got here, we subtracted, right? Always go back to long division. You multiply x times whatever this is, place it here, and subtract that black text. Subtract it. So do this. Put a minus sign around this. You're subtracting the entire thing. What's x squared minus x squared? 0. It's not convenient. It's on purpose. That's why we were searching for a value to get here that is the same as this value here. So you get 0 there. Then you go ahead and do this. Look up if it helps. 2x minus negative 3x. Minus a negative means? Yeah. So it's really 2x minus negative 3x, or 2x plus 3x, thus giving us 5x. All right. So far, so good? Now, if this were a number, you would bring down the next digit. If this was like 5 into 129, I would do this. I'd put a 2 here, get a 10 with a 2 there, right? Then what would I do? I'd take the 9 and bring it down. And then I'd say 5 goes into 29 5 times. 5 times 5 is 24, giving me a remainder of, 5 times 5 is 25, give a remainder of 4. R4. Same idea approaches here. So bring down that 4 at the end. Go ahead and take this 4 and bring it down. The same way we brought down the 9. Then we have to ask ourselves the next question. What should go, and look up when I'm saying this so you can see. What should go here? What should go here? So that when I distribute it to both of these, I get the same as what I see here. Mike?
No,
I saw a hand, sorry. Niall?
no, yeah.
I want to get this quantity right here. Currently I have x. What do I have to put here and multiply by x to give me 5x? What's missing?
5.
Just 5. I saw your hammer. Okay, just the 5 there. And think about it for a second. 5 times x gives you 5x. 5 times negative 3 gives you negative 15. Again, not a coincidence that the 5x repeats itself. That's the goal of this process. But we need to remember that we subtract what remains here. Subtract this whole thing. 5x minus 5x, again, is 0. Then I have 4 minus negative 15. 19. Now, my answer is clearly x plus 5. See it at the very top? Remainder 19. But think back to mixed numbers. What would this answer become? Let's split the page. On the right, what would that answer become as a mixed number, Niall?
X plus 5.
On the right side first. Over here.
Oh.
What would the answer look like if I wrote it as a mixed number?
25 and 4/5.
25 and 4/5. Niall got that because it's ready. 25 and 4/5. Do the same thing. It's this and 19 this, or over this. So what does it physically look like?
X plus 5 times 18 over x minus 3.
And believe it or not, we're going to put a plus, because there's really a plus sign here. We just don't show it, right? 25 and 4/5, there's really a plus sign there, just not shown. So x plus 5 plus, 19 over, in this case, x minus 3. Again, the remainder over the divisor is always the fractional portion. Okay, so this looks kind of weird. I understand that. Okay, it looks kind of weird because you're getting answers with variables in them, but you're dividing variable by a variable. What was the degree of the dividend? The dividend is what's under the division sign. What was the degree? 2. It was x squared, right? And you took x squared and you divided it by something with a degree of 1. The divisor, x minus 3, is x to the first. If you divide something that's squared by something that's linear, you have to get an answer that is linear. If it was cubed to start underneath, and you divide it by linear, this would still be x squared. Think about the degrees and think about your fraction rules. And your rules of exponents always hold true. So if you divide something like x to the 5th by x to the 2nd, that's just x to the 3rd, right? So if you had something like this, and on the outside it was x squared plus something else, and you divided it, the answer you get at the end has got to be x to the 3rd. Because the only way this works is by putting x to the 3rd up here. X to the 3rd times x squared gives you x to the 5th. That's how this will cancel. So again, look, in our case we had x squared over x, we got x as an answer. X to the 5th over x to the 2nd will give us x to the 3rd as an answer. It's always going to work out that way. The highest degree of the dividend over the highest degree of the divisor will always give you the degree of the quotient. Okay, every time that will work out that way. But this again is our answer right here. And this is the remainder portion, like the mixed, the fractional part of the mixed number. This is like the integer part, the 25 over there of the mixed number. Okay? Now, it looks like this is just busy work. It's not. The whole concept that we're trying to get at, and we're going to see in the next example now, is the significance of the remainder. And we haven't seen it yet. Let's wait till the next example and then we'll talk about it. Divide 2x squared minus x minus 3 by the quantity x plus 1. You can try it on your own if you want to get a head start. I'll go through it one step at a time. Okay, feel free to try it on your own though. Now remember that you're dividing the quadratic by the monomial. So you have to know what's getting divided by what. So we start underneath with a 2x squared minus x minus 3 and an x plus 1 out front. Now, what needs to go in this blue box so that when I multiply it by the quantity x plus 1, I get 2x squared right here. I need to get a 2x squared there. Mike, what do you got? 2x. 2x times x is indeed 2x squared. That's the first one. Then I take 2x times 1, which gives me 2x. And now I have to remind myself that I'm doing long division, so I need to subtract. 2x minus 2x is, again, 0. Negative x minus 2x is negative 3x. What do I do next? Ben.
Bring down the negative 3.
Good. Bring down the negative 3. So I have negative 3x minus 3 now. What needs to go up top so that I get negative 3x right here? Remember, you always got to get the same thing there.
Negative 3.
Negative 3. Negative 3 times x gives me that negative 3x. Negative 3 times positive 1 gives me negative 3. Interesting. Now I need to remind myself to subtract this whole thing. Negative 3x minus negative 3x gives me, what is it? 0. Negative 3 minus negative 3 is also 0. So as a result, what's your remainder?
0.
Your remainder is 0. Or you don't have one, that's fine, yeah. Your remainder is 0. Well, if I divide 28 by 7, what's the answer, everybody? 4, right? 4 times 7 is 28. What's the remainder? So when the remainder is 0, it means that this number divides evenly into this number. Agreed? That's what a remainder of 0 means. So 4 and 7 are the factors of 28, aren't they? So as a result, what can you conclude?
X plus 1 and 2x squared minus x minus 0 are factors of 2x minus 0.
Yeah, this at the top and this on the side, those red circles I just circled, are the factors of the dividend. Again, your answer was 2x minus 3 with a remainder of 0. That's fine. Well, if 2x minus 3 divided, or if x plus 1 rather, divided evenly into it, it means that this times this is really what was underneath. Okay, again, the quotient times the divisor gives you the dividend. That's that statement at the bottom there. So you should jot this down. If the remainder is 0, the quotient and divisor are factors of the dividend. Use 4 and 7 to help yourself. Again, here we noticed when the remainder was 0, we recognized that the quotient and the divisor were factors of the dividend. Well, now the remainder came out to be 0 here, so the quotient 2x minus 3, the divisor x plus 1 are factors. These are factors of the dividend. So I was able to write that last statement. This is true. It is not my answer. I'm just writing that statement down. Little asterisk, okay? Okay? Does that make sense, the idea? So it's really important that you understand that when the remainder is 0, that the result and the divisor are factors. Alright? It's a little bit tougher because it's cubic. Let's just practice this one. This idea of the remainder being 0, we're going to go into the next lesson with. It's going to carry us over. Now, if I'm dividing this into here, what might I have to do? Notice something interesting about this. How many terms does the dividend have? How many terms? 3. But when x is cubed, shouldn't it be 4 terms? What term is missing? The squared term. Good, Mike. The squared term. So it's really this. Oops. It's cubed. Sorry, it's cubed. Okay, believe it or not, I would write it like that. A placeholder is very useful because in a minute, if you pick a number to put up top and multiply it through, you're going to get a bunch of mistakes. Or you're going to get the numbers aren't going to line up properly. So write yourself a little note. When the dividend is missing a term, put a 0 placeholder there. I'll circle or underline that in blue. Right there, okay? The 0 placeholder. Charles, tell me what I should put in the first spot up top.
3x.
3x. Why not just 3, Charles?
Because it has to cancel out.
I need to get a 3x cubed right here. So 3x times x squared gives me 3x cubed. What's 3x times 3x? Anybody? 9x squared. That's positive. What's 3x times negative 5? Negative 15x. Now, I cannot just carry down. I need to remember to subtract this. Put a big parenthesis set like this and subtract that whole thing. Again, 0. Then we have 0x squared minus 9x squared gives me negative 9x squared. Do you see why the placeholder is useful now? Okay, the 0x squared placeholder reminds me to subtract 9x squared from that. Then I've got negative 2x minus negative 15x. Minus a negative 15x is really positive 15x.
13x.
Good, positive 13x. Again, negative 2x minus negative 15x is positive 13x. Then I carry down what value? What value do I carry down, Nina? The negative 4. And then I recognize the fact that I need to get a negative 9x here. Negative 9x squared here. It's got to be negative 9x squared there. Remember, whatever you see here as the first term needs to be repeated right here. Okay, whatever you see here needs to be repeated right here. So what should go up here so that when I multiply it, I get this times this, giving me this. See what I mean?
I was just going to say, the 2x is headed to some positive,
Where are you at?
or the negative 3x cubed.
Oh, yeah, it should have been a positive too. Thank you. I made a typo error. That should have been a positive up there. If that's a positive, this just changes to be 2. Make this a 17 instead of a 13. Okay, that's the only change. Make that a 17. Thank you, Sabine. So back to the question now. What value goes here so that we multiply by x squared? We end up with negative 9x squared.
Negative 9.
Negative 9. Negative 9 times the x squared gives us negative 9x squared. Negative 9 times 3x is negative 27x. Negative 9 times negative 5 is positive 45. I remember to subtract this whole thing and go through the motion. Do you see how this is easier as you practice? That's what I was getting at in the beginning. Okay, reminding yourself to subtract. Negative 9x squared minus negative 9x squared is 0, as always. 17x minus negative 27x. 44x, right? I changed it to 17, don't forget. Because we made the mistake. I made the mistake earlier. So 44x in that case. And then negative 4 minus 45. Negative 49. Now, at this point in time, I can attempt to go further, but here's the problem. My divisor is x squared. If I put anything up here, like a 2, 2 times x squared gives me 2x squared. I can't subtract x squared from x. So what does that mean?
44x minus 49 is the remainder.
That's the remainder. Whenever what you have here has a degree less than your divisor, it's the remainder. The divisor's degree is 2. The number you have down here has a degree of 1. So this is the remainder. So my answer is 3x minus 9 from up here. Okay, 3x minus 9 plus 44x minus 49 all over the divisor you started with. X squared plus 3x minus 5. Alright? This will be used a lot in the next few sections, a real lot. Okay, so you can't just ignore this and say, oh, I get it. You gotta go home and practice. This has to be like second nature. Okay? In the next lesson, we're going to do something called synthetic division, which is another way around this, but we still need to use long division later on. When you don't have, you're going to see tomorrow that synthetic division only works in certain cases. Okay, so we need to know how to use both of these techniques. Right? You guys have, what, 4 days, right? And then I see you again on Tuesday for 8-4. Tuesday's day 6. Okay, so I don't. So I see you on, actually that's perfect, because Tuesday is a C day for Mass. So we don't at least have to have like a shortened period. We have full period on Wednesday. Alright, so you have a lot of time. What else should you do over the weekend probably?
Problem sets.
Try 1 and 8-2 at least over the weekend, the problem sets. Okay, get a head start on that so next week you're not bombarded with stuff.